Good morning, students. Continuation of the center of mass, the seventh topic, system of particles and rotational motion. In this we are going to discuss how to find the center of mass of the triangular lamina. Lamina means thin plates made of any material. How to find the center of mass of this regular shape? It is irregular shape we are not taking. Regular shapes we discussed previously for the circular plate, rectangular plate, like that. No, for this triangular shape you have taken, center of mass itself is a geometric center we can take. If it is the equilateral triangle means all sides equal length, each side angle is 6 degrees if you take it means we can take the center of mass will be at the geometric center it. But if it is not need not be, if it is not exactly equilateral triangle, also how to find the other method is you have to divide the each side plate into small strips. You don't have to cut the plate, just draw the lines. For this small strip, the center of mass will be exactly midpoint. Similarly, one more strip if you imagine at the center of mass at the midpoint. Like that you take all the lines parallel to each side. Like this also, this side also, this side also, this side also. And from center you take all the points and join all the points. This is called as a median. Similarly, from this side also you can imagine. This side also you can imagine the small strips or lines. Center of mass of all these lines will be the midpoint of each line, each strip. And join all these, you will get the median. Similarly, from this side also you can take this similar to that, and also parallel to this side. Parallel to this side also you can take all sides. Then you will get the medians, middle points of each sides joining to the corners. The lines are called as the medians. This is called as the medians. So center of mass of this triangular lamina can be found with the help of these methods. This is called as the intersection of the medians is the center of mass. Medians of each side. Intersection means meeting point. Intersection of medians of each side will be the center of mass of triangular lamina. Next is, if it is an irregular shape, how to find the center of mass and center of gravity. And before that we will discuss when does center of mass and center of gravity coincides. Center of mass, this is one more question. Center of mass and center of gravity coincides. Coincides in uniform gravitational fields. Uniform gravitational fields means G equal to constant. Center of mass and center of gravity coincide in uniform gravitational fields when acceleration to gravity G is constant, or for small or non-extending objects. Small or non-extending objects. If you take any small objects like this also, the G changes from place to place, but for small object the G in this area, G in this area, in this small area is constant, approximately 9.8 meter per second square. So when G is constant, the center of mass for this body and center of gravity will be at the geometric center. This is of course symmetrical body. Both will be at the same place. That means center of mass and center of gravity coincides for the symmetrical bodies which are also small size, not bigger objects. If you are taking the small side, at this point you will find the center of gravity. This is the center of mass. The same point is also center of gravity. CG and CM coincide for the small objects because G here is constant. This is G2 if I take, this is G1. G1 is equals to G2. That is called as a uniform gravitational field. And the small objects automatically G is constant in that area. In that case, the center of mass coincides with center of gravity. But if it is when they do not coincide, if you take long objects, very big objects, if you have taken extended bodies, for extended objects or bodies, center of mass may not coincide with the center of gravity because value of G of acceleration to gravity may change. May coincide means may change or may not be changing, but generally on the earth surface G is not constant all the places. May change from place to place, or it's not constant all places we can take. So the extended object means if I take very long rod, imagine one end is at the equator, other end is at the poles. G at the poles is more than G at the equator. G at the equator is minimum value find for the earth surface. Earth is spinning about its own axis, rotating about its own axis. At the equator, G equator, at the poles, G poles. G equator, acceleration to gravity G at the equator depends on the rotation also, and also distance from the center is more. At the poles, distance from center is less. The radius at the equator is more and polar radius is less by 45 kilometers approximately. Due to that reason, the G value, less distance indicates more G value. G is inversely proportional to R square, distance square from center of the earth. So in these cases what you get here is G value is more at the poles than at the equator. So this more than at the equator. G is not constant. So if you imagine a very big rod you have taken from poles to equator, if you have taken, then the G is different. Mass balancing point is center of mass. So left side right side mass may be same for uniform object. Here is center of mass auxiliary point. But if the G equator, here the G poles is more than G equator, here weight is more. So center of gravity depends on the weight, means acceleration to gravity G. So this side weight is more than this side weight. In that case center of gravity is close to larger weight side. This is the center of gravity. Center of gravity do not coincide with center of mass for extended objects or big objects. Where you can find the extended objects naturally is clouds. If you take the clouds, they have the very big size, like big clouds carrying the rain. They may occupy very large size. Some kilometer size will be there. So in that areas, if they are on the hill areas, hills may be there on their surface, valleys may be there. In that cases, the G value is different at different places. So here G2, here G1. Because of the mass distribution, center of mass may be here. But uniform, if you take the cloud also, center of mass at the midpoint we can take. But G is different. If G2 is greater than G1, center of gravity is related to the weight. So this right side weight is more than left side weight for the cloud. In that case, center of gravity is close to larger weight side. Center of mass do not coincide with larger weight, coincide with the center of mass for extended objects. Example for the extended object we can take clouds, big clouds, and raindrops also we can take. Example of extended objects for which center of mass and center of gravity do not coincide is clouds, big clouds. Or raindrops from the clouds. The raindrops falling from the cloud may spread over the large areas. So the raindrops coming from the same cloud, they are coming from the single object. The force is only external force, gravitational force uniform for all, internal force is 0. In that case the raindrops falling, initially center of mass of this whole cloud is here, for example, which is broken into droplets. Droplets are falling everywhere. The resultant center of mass of all the water droplets will be taking the only linear motion. Just like the cloud falling straight, all the center of mass of these particles, when after falling on the ground also, will take the same straight line path. They may spread in different directions, but center of mass will be at the same place on the ground. So center of mass is not affected in this case. But they are spreading over large areas, so G1 here may be different from G here. Or this we consider all these droplets as a single system of particles. In such cases, acceleration to gravity is not same over large areas. Then center of mass and center of gravity do not coincide. Center of mass take the same linear motion here, and center of gravity may not coincide with the center of mass after falling on the ground. So this raindrops altogether is taken as a extended bodies. Is a system of particles, many particles coming from the same object. We take it as a extended objects. This is the case of the regular objects. If we want to calculate the irregular object center of mass, then for small objects we can take center of mass of, or better take it as center of gravity. They will ask you CG of irregular lamina plate. If you have taken irregular plate, or even for regular also we can use, of course, same procedure. of lamina. Here in this case, for small object, no, small lamina you have taken means CG and CM coincide. Means same point is going to be center of mass also for small lamina. Means non-extending object you are taking. That is irregular shape you are taking. If you take a plate of irregular shape, how to find center of mass of this? You have to make the holes at different points, edges. If not holes, by any other methods, you have to take a suspend this whole plate with the help of a string. Object automatically adjusts. If you hold a suspend like this, weight is here, the weight will push down the object, and the object will suspend automatically such that the vertical line passing through the center of mass will be always towards the center of the earth. Center of mass means here we are talking the center of gravity. If the center of gravity is here, the weight will be acting for the whole object from this point only. The weight will be always acting towards center of the earth. So the line from this thread, you take a vertical line. Just to take a vertical line like this on the plate. When you are suspending it, what is done is for the thread, we take one weight also here. The weight is suspended to the thread, and the thread is tied here. Or else without this weight also, we can take a scale and then draw the vertical line passing through this along this thread like this. Okay, and the same thing you have to do by tying this string, is a thread, to the other hole. Shift it and hold, suspend it. Then again it will be suspended such that the vertical line passing through the center of gravity again. So you will get the line like this. Similarly, line like this. They all meet at the same point. That is supposed to be center of gravity and coincide with center of mass. So at different points you have to make holes at the tips. If you take the hole here, for example, it will bend like this. You take a vertical line like this and make a hole here and suspend it like this. It is automatically suspended such that this vertical line passes through the center of gravity towards center of the earth. You can take a vertical line. Like this at the different points you take vertical lines, and the intersecting point itself is supposed to be the center of mass and center of gravity. Next is path of center of mass for bomb pieces. When bomb explodes in air. This also may be asked for 1 mark question or may be asked for explanation of 3 marks question. If you take a bomb, throw it into the air at some angle, it takes the parabolic path, it becomes a projectile. Bomb thrown into the air at some angle means it becomes equal to projectile. What is the path of the projectile taken is parabolic path. It takes parabolic path. So I am throwing the bomb at some angle theta. Theta is the angle of projection, and u is initial velocity. You don't have to explain these points actually. This is the initial velocity you are throwing. It takes the parabolic path and falls here. Somewhere in the middle, in the air, this bomb broken into pieces. They fly in different directions. And only force acting on these all objects is a gravitational force. Explosion of the bomb takes place from inside force, that is supposed to be internal force. Internal forces do not change the center of mass. The path taken by this bomb without explosion is this point. This is a path which is nothing but equal to parabolic path. And it falls on the ground. So if it explodes here into pieces, the pieces will fly in different directions. They fall on the ground different places. But if you calculate the center of mass of all these particles by means of m1 x1 plus m2 x2 and so on by m1 plus m2 plus mn, like the particles how many you take, all the particle center of mass if you calculate it will be here only. If the bomb not broken, it will be falling here. If all the pieces are spreading in different directions, their center of mass will be here only. Neglect the wind, you have to neglect here. The force acting is uniform in all directions. That force is only gravitational force. Gravitational force is only the external force acting actually. External force can affect the center of mass, but here external force is uniform for all and affecting the same way. So that you do not consider here. That is only pulling them downwards. So final effect is that only internal force only taken. Internal force do not affect the center of mass. Hence, the bomb, wherever it is falling, the center of mass of all the particles will be falling at the same place only. Particles may not be at the same place, they spread in different directions, but center of mass will reach the same point. The point is that if the bomb is projected into the air as a projectile, it takes a parabolic path. If it explodes in the air, somewhere in the air, mid-air, it breaks into several pieces flying in the different directions. But center of mass of all the particles still take the same parabolic path that would have taken by the bomb without explosion. Bomb takes parabolic path. Okay, this one already mentioned. No? Next is, if bomb explodes in air into several pieces, the force is internal. That point is important. Internal force does not affect the center of mass. The bomb explodes into several pieces flying in different directions. Different directions. Then center of mass of all pieces take same parabolic path. Same parabolic path that would have taken by the bomb without explosion. If bomb explodes in air into several pieces flying in different directions, then center of mass of all pieces take a same parabolic path that would have taken by the bomb without explosion. Okay, this point diagram is not of much important, but if you draw it is fine. There will be explanation, maybe ask for 3 marks question, or may take 1 mark question also. They may ask what is the nature of the path of the particles at center of mass if the bomb explodes, means just write same parabolic path as that of the bomb. Just 1 or 2 problems I will discuss. From the center of mass. Next we will start a rotational motion or circular motions. Example problems 1. Coordinates of center of mass of system of having the masses 3 particles 2 kg, 3 kg and 4 kg. Center of mass, find center of mass. 3 particles of masses m1, m1, m2, m3 have values and coordinates 2 kg, 3 comma 2 comma 3 kg, 1 comma minus 4 and 4 kg minus 3 comma 5, all in meters. Distances are in meters, or length you can take, or in meters. Find coordinates of center of mass. Find x comma y coordinates of center of mass, xcm and ycm. When any problem, what it do is we require the masses and their coordinates. So if you take the mass m1 is 2 kg, coordinates are x1 and y1. This is m1, and the next mass is respectively in the same order you take. This is going to be m2. What are the coordinates is x2 and y2. 4 kg is m3, going to be x3, y3. Separately I am writing the values. Answer: masses m1 is 2 kg, coordinates x1 is 3 meters and y1 is 2 meters. This is in the xy plane only. Sometimes they will give you z coordinate also, but here in this problem we have only x and y coordinates. This is 2 meters. m2 is 3 kg and x2 is 1 meter and y2 is minus 4 meters. m3 is equals to 4 kg, x3 is minus 3 meters, y3 is 5 meters. So xcm, if you want to calculate, no, x coordinate of center of mass is xcm equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. 3 particles are there, so 3 mass you have to take. If any number given, that number same you have to take. Substitution of these values will give m1 2 kg into x1 3 meters plus m2 3 kg, x2 1 meters, m3 4 kg, x3 minus 3 meters by m1 plus m2 plus m3, 2 plus 3 plus 4. So xcm becomes 2 3s are 6 plus 3 plus minus 12 by 9, which is equals to 6 minus 12 is minus 6, minus 6 plus 3 minus 3 by 9, which is equals to minus 1 by 3 meters. And similarly y coordinates of center of mass is y same equal to m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. m1 is 2 kg into y1 2 meters, m2 is 3 kg. m2 is 3 kg and y2 is minus 4 plus m3 is 4 kg into y3 is 5 meters by m1 plus m2 plus m3 total mass 2 plus 3 plus 4 9 4 minus 12 plus 20 by 9 is equals to This is going to be minus 8 plus 20 is 12 by 9 meters, which is going to be 4 by 3, 1.33 meters is the y coordinate. Sometimes they will give you, ask you position coordinate. Position coordinates in case if they ask you. Here only xy only asked, but if they ask you position coordinates, position vector of center of position vector, if they ask you of center of mass. Position vector means you are taking terms of the position components of this x and y, means xcm rcm is equals to xcm I plus ycm j you have to take, which is nothing but equal to rcm is equals to xcm is minus 1 by 3 of I, ycm is plus 4 by 3 of j. If they ask the displacement, means value of that, if you want magnitude, means to say rcm is equals to under root of minus 1 by 3 square plus 4 by 3 square equal to dash, that you have to find out in meters. This is the displacement of the center of mass from the origin, it means. One more problem we will do. Example problem number 2. Three particles of m1 is equals to 20 grams, m2 is equals to 30 grams, m3 is equals to 50 grams, have velocities 10i, 10j, 10k, 10i, 10j, 10k respectively. They are given in terms of the vectors. Find velocity of center of mass. We will discuss this problem again in the next class. The time is up for this session.